There we go. Okay. So we'll just miss that first part.
Yeah.
Okay, so think about triangles. If you're showing triangles are congruent, how many parts are in a triangle? How many sides? How many angles? So this proof could be really long because you have to show all 6 parts. Can you imagine if you had a pentagon? 5 angles and 5 sides? Octagon? Nonagon? I mean, the whole lesson is trying to kind of get you to understand what you need to do. Now, thankfully, our proof today is only a triangle. So it's only the 6 parts. But it could get really, really lengthy, all right? Corresponding parts, they just ask you a lot about this. So corresponding parts, if you look at the diagram, this is the best way to kind of explain it. Do you notice how there's like 1 mark, 1 mark? 2, 2, 3, 3. So sometimes they ask you to list all of the parts, and it's really lengthy. So go to number 3. We'll kind of start it, but we may not finish all of the parts. Again, the finished filled-in notes are all online, where it has every single thing written down. It says identify all of the congruent corresponding parts. So you have to list the sides and the angles. So like Ivy, what do you want me to do first? Angles or sides? Angles. So you literally just pick an angle from whichever triangle. Let's say you pick the left. Let's say you pick J. You look at J and you have to make sure which one goes with J. So you've got 2 little marks, and so it goes to what letter? T. And so then you say T. And then you do the same thing, you do the next letter, so then you pick the next one. You can either pick L or K, it really doesn't matter, you're going to end up doing them both. So if you pick K, it goes to what? S. And then the only one left is L, and the only one left is R, and just make sure. Now, can I just tell you that on the quiz, everybody ready? Look at this is what it looks like on the quiz. So on the quiz, they don't ask you to list all 6 because, I mean, I guess in your mind, you should want it to. It's time consuming, but could you imagine, like that's a good 6-point boost of a grade if you miss something else, right? So on the quiz, they don't ask you for all 6. They just pick a couple random ones. Do you see the JK? You have to make sure the letters match. I'm going to switch to a pencil and make a mistake, so watch mine. This is wrong. Notice J should go to, look at J, it should go to T. Now, I'm not super picky in the sense of as long as you do have the right letter combination, I will give it to you. But I bet somebody on Monday is going to say, Mrs. Twig, I wrote my letters like reversed of yours. Well, it depends on if that's correct. So it is supposed to be letter for letter matching. So it's a little time consuming, especially for some of you who details are not your thing. Like if you're just kind of they look about the same, then this lesson is going to be difficult because they want it to match precisely. Does that make sense, or do I need to finish off the other 2 sides? No? Some of you are struggling and I don't know what to tell you because you can do this on your own. Like I don't need to teach it, but you're going to be tested on it. So if you care about your grade, then you better pay attention here. It says write a congruent statement. Up here, the congruent statement is essentially putting all of this together. It's kind of like a summary. Now, you have to watch your order of your letters. This is the one place I will mark you down. This one, the segments, you can flip-flop them, okay. But the congruent statement has to be letter for letter. So if we were looking at this, how about Lauren? You pick, give me a combination for this triangle. You don't have to go alphabetically, but I just need these three letters. Okay? Now, she started with J. I just have to make sure which one J goes to. Now, I already have it listed here. So do you see how she went in order? J, K, L. So I might as well just go in order, T, S, R. Look up here for a quick second. Notice how I just switched the order? You can do that. Then over here, you just have to make sure that it would be T, R, S. You just have to make sure first, second, and so on. Okay? That is called a congruent statement. If the figure is difficult to draw, a tiny little shape like this, you can leave the shape off and just put the letters. I have seen them draw little trapezoids. I've seen them draw little pentagons. But I feel like if you start to get up past a pentagon, like could you imagine trying to draw like a little octagon right there? So for the most part, sometimes when you get above triangles, they drop the symbol out front. Sometimes they don't, but as you keep going up higher, they will drop that symbol. So take a look at 4. Is that the correct congruent statement? And if you say yes, you're done. If you say no, then you got to fix it. So look at it. How about Jackson? What are you saying? Yes or no? No? I'm going to put no here. So what are we going to fix? Which order? On the first, the second? The second? So what needs to get changed? So M goes to Y, N goes to X, and P goes to Z. You're correct. Make sense? Now Jackson could have switched to the left side if you wanted. So there's definitely more than one right answer. Feel fine so far? Okay. If you turn to the next page, number 5 reminds me a lot of your problems from yesterday, only you've got this congruent statement. Do you see how they dropped the little symbol off the front? They just put the letters. So you still have to find the values of X and Y, but there's not so much like linear pair today. There's not so much triangle sum theorem. So what you do is you look over here at your picture and you see that there's an X and there's an X. You can definitely go for whichever one you want first, but one of them is going to be harder than the other. Would you agree that the combination of the Y and the X together would be more challenging to do because it's 2 letters? Okay, so how about we try to tackle this one first and just get the X? That's QR. The last 2 letters go to the last 2 letters here. So look where FG is. Can I make an equation from this? Yeah, it wouldn't be too hard. So I take the one from the left, the one to the right, and then now you just have to solve it. So move the 4, divide by 2, and you got half of your answer. So now how am I going to get Y? Because when I look through this picture, hold on, there's only one of them right here. There's just the one location. Ben?
You take the X and you plug it into that and
So put it here.
yeah, and make it equal and do that equal to the H.
Why 68? You just pick a random number?
No, because that's congruent to that angle.
How do I know it's congruent? Why can't it be congruent to 102 or 84? It looks acute.
Because if you flip the original image, it matches that image.
Okay, if you were to rotate it, it would. Or you can also just look up here. I was just kind of trying to play devil's advocate. Q is the third letter, so then the third letter here would be F. So if you look at the congruent statement, F goes to Q. So Ben is right. You're going to take 68 and you're going to set it equal to 6y plus, but instead of putting x, we're going to change it to our other number. The bad thing is, though, is if you mess up the x, you just messed up the y, because it's a chain reaction. So subtract 8, divide by 6, and you've got it. How do you feel with this? You feel like you can do these? Okay. This is where I said I apologize at the beginning. I already made some notes to myself to change it for next year. But go to number 8. It kind of goes better if you go to number 8. Now, number 8 does not give you a congruent statement, but do you notice how things are marked as equal? So on number 8, I want you to try this one, and I want you to tell me this angle of BDC. So take a minute here and see if you can come up with that answer. All right, try to get your final total. So again, this is a similar question to what we had in yesterday's lesson, only now they're just kind of, I want to say overlapping them, but they're making it a little bit more of a puzzle game. So you're going to see very similar questions. The answer is 105. Now, I'll quickly go through it. I'm not saying you have to start the same way I do, but I'm noticing 30 and then this is 30. I'm noticing 45 and then this is 45. So part of my thinking is if I could find this angle by n, then I could use triangle sum theorem to get this one. So essentially I need this angle to add it to the 30. So what I'm thinking here is if I add these two together, 30 plus 30, and if I subtract that from 180, that's triangle sum theorem, then these are a linear pair. Now, I know these are vertical, but this one over here is not necessarily going to help me. So now using this, I'm going to do my triangle sum theorem. And so I got this top piece to be 75. Then you need to add them together, 75 and 30. So again, these questions are little, almost like little puzzles that you have to just pick kind of a spot and do what you know. And it does require some of your previous knowledge of like linear pairs, verticals, Even you're going to see some alternates and correspondings come back, okay? All right, 10. I'm going to skip 9. If you want to look on the answer key or whatever, you can see that, or I can tell you what 9 is. But I want to touch on 10.
Hey, can you tell me what 9 is?
33.
Okay.
10. Take a look at 10. We got to touch on this one because it's a system. And some of you I've never had in algebra before, so I don't have any idea of your algebra skills. I could look it up, I guess, in the computer, but it doesn't always tell me, like, you know, exactly like what you got on chapter 5, which was the systems of equations. So it wants us to find the value of x and y. If we take a look at this congruent statement, this is going to be really helpful. Notice they're giving me t. T goes to y. So t and y go together. 28 is equal to 8x minus 6y. So I'm going to lightly cross this off because I've used these. I have 2 left. Hopefully they go together, or I've got a serious problem here. U should go to z. U, z. Okay, they match. So I'm going to put the number first because I like everything lined up. I have a little OCD. I want my numbers on one side. I want my letters on the other side. This is the difference from today's lesson to yesterday. In yesterday's lesson, you didn't have to solve a system. Yes, you had 2 variables, but you could get one first and plug it back in. This lesson, you've got a system that you're going to have to solve. I highly doubt anybody wants to do graphing because these are pretty large numbers to go on a graph. The number is nice, it's not a decimal, so you could graph it, but you got to decide your method. So do you need me to help you on how to solve systems? Because this is not really algebra class, but I'm happy to help you because otherwise we're not too far from being done besides the proof. Yes, you need help, or are you guys good with systems? I'm not good? Emma says you're good. Scarlett? Okay, what method are you going to use? Again, I doubt we're going to pick graphing. Do you want to use substitution or elimination? Sir, are you going to get y alone? If you would have let me pick, I would have picked elimination, so you just have to pick. You want elimination? Okay. I'm assuming we're going to multiply the second equation. Do you either want to get these to 8 or do you want to get this one to a 6? 6? So I got to multiply everything by 6. 132, just check my math. Last hour they said to get it to an 8, so I haven't done 6 times 22. Yeah, 132. So I just multiplied 22, 4, and y by 6. Okay, I'm going to add these together because these are opposite of each other. So I'm just going to add. 160. $32. So 160 divided by 32 is 5. Then now you just have to plug that back in. Probably go to this equation because it's nice and basic. So if we plug 5 in here, that's 20. 22 minus 20. Done. You do have to solve systems on this quiz and on this test. So I definitely wouldn't mind showing you guys a matrix because I think it will help you. Not just on this quiz, I just think it will help you in math in general, just knowing how to do a matrix, but it is not taught in any of our textbooks. So matrix is just something that I've picked up over like just time, whatever, hundreds of math classes I've picked up. All right, questions so far? So, listen, the only thing we have left is the proof, really. If you look back to this page, and you don't have to turn, but if you look at this page, they're just giving you a couple extra theorems to remind you about before you approach this proof. This section is just telling you that you can still use reflexive, symmetric, and transitive. You really only need reflexive. Reflexive is going to be a fairly common property. Remember how we used to use substitution a lot? Reflexive is used quite a bit. This other one, third angle theorem, is definitely one you need to know. Third angle theorem, to me, almost should be a corollary because it kind of sounds... Okay, so let's say I give you a triangle. Let's say this may not be 90. I was just trying to draw them so that they look equal. Let's say that this is 80 and this is 20. And let's say this angle is 80 and this is 20. So far, so good? If you know two angles are congruent, so you've got angle A and angle B. If these are congruent to angle X and angle Y, then wouldn't the third one have to be equal as well? I mean, by triangle sum theorem, what other number are they going to be? So to me, this should be a corollary. I'm not 100% sure why it's not, because it kind of flows from the next one, but it's called the third angle theorem. We use this in proofs, so like you do need to know this one. And so I think we're just going to hit the proof, but number 7 is trying to get you to this idea of 6 parts. You've got to show all 6 parts are equal. Well, this isn't a proof. This was just leading you to the proof. Notice if you look at the picture, do you see how they give you one side, 2 sides, so you have to show the third side. Notice how they give you 2 angles? You'd have to show the third angle. So this is just trying to lead you to get ready for the proof. And again, I apologize that these are a little out of order. This is the way they are in the student journal. And so again, just having been through it, yet a lot, I'm going to probably reorder it. So let's hit the proof. I know that this is really your favorite thing in the entire world.
Oh, you have a question?
Yes.
Have you ever used the fruits?
It's hard for me to give you an honest answer for that because I don't know what the new book, because when I used to teach geometry, it was from the old book. In the old book, there was very few. I don't know what this new book, because again, ever since we switched buildings over here, they tried to keep geometry at the other building because that was supposed to be like 10 and up. But then everything just got kind of so crazy with schedules and different things that now there's classes over here for 10th, 11th graders. So I honestly don't know. I'd have to look at the book, to be honest with you. Okay? All right, proof. I think one of the steps got cut off here because it's right at the bottom, so I apologize. There's actually 9 steps instead of 8. Yay, I know. Woohoo, real fun. All right, here we go. Do you see how it says diagram? Everything that's marked in this diagram is really a given. So I'm not going to make you guys recopy this and say, don't write this. I'm not going to make you guys recopy and say angle A is congruent to angle C. And then angle AB is congruent. I'm not going to make you recopy that. We can just say diagram. But what this word is telling you is everything that's marked in this picture is what's been given. So take a look at this picture. We have to show or state all 3 sides and all 3 angles. So let's start with sides. How many sides out of the 3 are marked congruent? 2, right? we've got sort of left, right, and then we've got like the bottom, left, right, correct? We need the third side. Isn't the third side right down the middle? Isn't that the third side? If you were to pull these two triangles apart, wouldn't they have the same BD side to them individually? So that's all you have to say. You have to say that BD is congruent to BD. This is the third side of the figure on the left, the third side on the figure on the right. You have to say that, and it's reflexive. Again, I know that sounds stupid, but I can't tell you how many manuals I've seen that literally tell you like things that you think somebody should know. But probably because they don't want a lawsuit, they put that stuff in there so you can't say, well, you never told me. Again, why does McDonald's have to put caution hot on a coffee cup? You would think that if you order coffee, you would know it's hot. But they got sued and now it's on there. All right, our sides are done. It's going to take us this much work to do the angles. It kind of stinks. They give you one angle. You need to show the other two angles are equal. You can't start at the top because you don't have anything to do. So you have to start down here. What does this little corner thing mean? Okay, it means it's a right angle. So let's say that. ADB. If you want to say right, like RIGHT, if you want to spell it, then we're going to actually add a 10th step on. Now, how did we know this? Like, what am I going to put here? Well, it didn't say it was right. I agree with the definition.
But like it has this right square thing.
Okay, but that square thing actually means perpendicular. So it's definition of perpendicular. Ella?
When we're saying that ABB is equal to 90, are we saying that angle is
Yes.
equal to 90 or the entire triangle?
No, the angle. That's why I put an angle sign.
Oh, I did, sorry.
Yeah. Okay, remember, the goal is to get this left angle to be equal to this side. So how can I how am I going to get to that? Remember, you can't just jump and make an assumption. You have to be able to back up whatever you say with some type of definition, theorem, postulate, corollary, something. So what are we going to put there? They're not corresponding.
Oh, they are,
They're a linear pair. So we can put that. The left plus the right, left plus right, is equal to 180. This is technically linear pair postulate. Again, I will try to be as accurate as I can for you, so you're not seeing it demonstrated wrong. But if you just put LP, I would be fine with that. Okay, we're still not saying that they're equal to each other, but we're getting there. Look at inductively. Do you see how these are the same? Can't we put 90 right there? How are you going to justify that? Substitution. Still not saying they're equal, but we're getting there. Isn't the goal to show that this was 90? Now what? Ben?
When it says you do 90,
How can I say it's 90?
because 180 minus 90
So you use the subtraction property. Okay, now look at this. This one and this one. If they're both equal to 90, then they have to be equal to each other. Whew. Takes a lot of work to say they're equal to each other. All right, I've got two angles. I've got one, and then they gave me this one. So I've got two angles now. I need the third set of angles.
Oh, didn't we just talk about that? What's it called? The third angle theorem?
Correct. If you know two are congruent, then by triangle sum theorem, in a way, the third one has to be. So now you can say these top angles up here are congruent. So do your top angles. So I'm doing the left top, right top. So left top, right top. You can see my vertex is the same letter. And that's called the third angle theorem. So now I've got my third angle here. I've got three sides, I've got three angles. I've shown all six parts. So my triangles then are congruent. What are you going to put there? Yeah, the definition of congruent figures basically says, show me their parts are equal. Show me every part is equal, and I will agree that they're equal. So you just have to say definition of congruent figures. Guys, I realize this is a long proof. I do not deny that. However, that's the goal of this chapter, is to be able to show figures are equal. Now, thankfully in our chapter, they're not going to make you go above triangles. Could you imagine how long this would be if you had like an octagon? It would be insane. So, the next couple lessons, they are going to give you some shortcuts, okay?